Hello everyone. Today is December 21 and it's time to open a new problem in our coding advent calendar. There are 10 days till New Year and that means the end of our calendar. So there are only two problems left. Let's take a look at today's problem. Here is the problem. Possible bipartition. We want to split a group of n people labeled from 1 to n into two groups of any size. Each person may dislike some other people and they should not go into the same group. Given the integer n and the array dislikes, where dislike I equal to some array, indicates that the person labeled AI does not like the person labeled BI, right? Return true if it's possible to split everyone into two groups of in this way. Here is an example. 4 people, and here is a list of dislikes. 1 does not like 2, 1 does not like 3, 2 does not like 4. And we can split these 4 people into two groups. In first group there will be person 1 and person 4, and in a second group there will be person 2 and person 3. Second example, n equal to 3, and dislikes are 1, 2, 1, 3, 2, 3. So these people does not like each other, so it is a triangle, and in order to satisfy this requirement we actually need to have 3 groups, but we only have two. So that means 2 of these people must be in same group, which is not possible for our solution, so we should return false. And so on. So how are we going to solve this problem? Let's take a look at a dislikes array. It defines connections between people who doesn't like each other, and we can build a graph of these connections, right? This is the first observation. A second observation is that we only have two possible sets, two possible groups, and when we say person 1 doesn't like person 2 and 3, imagine we build a graph and we have node 1 and it has neighbors 2 and 3, for example. What does it mean? It means that 2 and 3 should be in the same group, right? Because we only have two groups. 1 is in one group, 2 and 3 are in another group. So having this in mind, we have to build another set of connections based on what we know about people who have to be in the same group, right? From this definition, person 2 and person 3 must be in the same group. If we face a problem that we have to put two people in same group but they does not like each other, we have a conflict, and in this case we can return false. If we were able to manage all these connections into two groups and does not face any problem during this algorithm execution, we can return true in the end. How are we going to group these people? Initially, everybody has own group, like a group of one. When we see that person 2 and person 3 must be in same group, we say that person 2 is in group 2, but person 3 should go to group 2, right? So, and eventually we will put all people in groups, and that's it actually. How are we going to do this? We need to use algorithm called union find. This is a common algorithm in graph theory, and we are going to implement it. But first, as we discussed in the beginning, we have to build this graph, right? We need to build graph from dislikes, right? How our graph would look like? We are going to use dictionary as in one of our previous videos, or two previous videos. Dictionary is in C#, is a hash map in Java or any other programming language. It maps integer into list of integers, and it allows us to find connections between any particular node and its neighbors. And we are going to send these dislikes into this function. Okay, how are we going to do this? We're going to go through list of dislikes. Okay, we took two participants. We need to initialize internal list. We need to add two connections. So this connectivity is bidirectional. So if person 1 does not like person 2, that means person 2 does not like person 1. So that's why we do this. And we done with our graph. What next? We are going to create a union find object of n+1 for simplicity, because people are labeled from from 1 to n, so it's not zero based. So for simplicity we will just not use the index 0, we will just address from 1. How this union find data structure will look like: it will be a separate class and this class will have two arrays. Parent and rank. This class should also have a few functions. So first it's constructor. We will initialize fields. And rank should be initialized with zeros. Why we initialize parent data field this way? Because initially every person is in own group. When we are going to merge these one-person groups, they will combine into clusters, and once we find collision in this cluster because of our definition of people who doesn't like each other, and then we found our case, our solution. So we will modify these data fields. This data structure should have find. This find function should say in which group any particular person is. Initially, person 1 will be in group 1, person 5 will be in person 5. If we have a definition that person 2 does not like people 1 and 5, that means people 1 and 5 should be in the same group, and we will map person 1 to person 5 to person 1, which means person 1 will be a group marker, and person 5 will be have a reference to person 1. I'll show you how we will do this. So if this array has value of its index, that means it does not have any reference to other group. That means he owns this X owns its own group, right? Or it's a head of a cluster. So if parent of x is not x, it means it refers to something else, and we need to find this something else. And since this okay, let's do this. Return find so we use recursion here. If parent of x is x, then we need to return parent x or x. This can be this recursion can have many steps, and we are going to use improvement in performance here. We are going to override this value with this find to make sure that even if at some point we have to go through recursion calls many times, this will be collapsed into one reference. So our graph of dependency from parent x to its next parent will be flat. So this optimization does this. So it's our find function, and we are going to have another function called union. We are going to union two integers and how are we going to do this? So first we need to find to which groups these integers are associated with. Next, if these items are associated with the same cluster, the same group, then we don't need to do anything because they are already union. Okay, next we are going to use the rank. The rank will tell us which so imagine we need to merge two graphs of objects which are, for example, flat, or one of them has is higher tree than another one. So based on the height of the tree, we need to define which tree to assign to the head of another tree. So the tree which is higher should be the main one. So its root will be root of both trees, of for both clusters. I know it's a little bit complicated, but you need to just carefully look through union find algorithm. Probably my explanations are not very good here, but I hope you will be able to understand. If rank of X cluster less than rank of Y cluster, then parent of X cluster of no Y cluster. Okay, so we take root of take this root and assign it to this root, which has higher rank. Else if, and vice versa, rank of X cluster is bigger than rank of Y cluster, then we need to do the opposite. Else if ranks are equal, so we need to just define who will be main. So let's do it like this. Parent Y cluster equal to X cluster, and a rank of X cluster plus plus. Okay, so X will have a higher rank because we join the whole subtree to its root. That it. We implemented our union find class, and how are we going to use it? So we created it, and now we need to go through all n people. Person equal to 1, person less than or equal to n, and person plus plus. If this person is not in our graph, that means it doesn't have any dislikes. That means it can be assigned to any group, so it doesn't matter if we handle this person or not. So if group does not contain key of this person, we just continue. Next, for each int neighbor in group in graph of this person, we need to first check if these two people are in the same group. If they are, not these two, like which people? This person and its neighbor. So if they are in same group already, that means we found a collision and we need to return false. If union find person equal to union find neighbor, then we need to return false. That's it. Otherwise, we need to union this neighbor with who? Let's merge all neighbors with the first neighbor of this person. That means first attempt will be to merge this neighbor to itself, and we have this case covered here, and we just return doing nothing. So like this. So we will merge this neighbor to the first neighbor of this person, and in case its first iteration, it will be the same person. Okay, in the end of this, we need to return true. Let's try and find some errors. 15. Okay. Okay, and cannot be defined. Okay, that should be correct now. And 54. Okay, yeah. Okay, all three cases are accepted. Let's try to submit. Okay, that's it. And our solution beats 95% of all solutions. And let's try to estimate the complexity of our algorithm. It is a little bit tricky, but this union find eventually all operations are big O of n or big O of so a big O of 1, so they are fixed fixed time. And here we need to go through all elements and all neighbors, so the complexity will be big O of n plus m, where n is the number of people and m is the number of connections. And the memory consumption will also be big O of n plus m, if I'm not mistaken, because because we need to build a graph with these connections. I think so. I may be wrong, I may be, but if you think so, please join me in comments and write some notes about where I'm mistaken and why. Whew, that should actually be marked as hard. I know it took me a longer time to finish it, but I hope you got the idea how union find works. Don't forget to learn new things every day, because in other case, someday you will be replaced by AI. Just kidding. Or not. See you tomorrow.